We are going to review parallel and perpendicular lines. Parallel lines are lines that do not intersect, so they go in the same direction. An example of what parallel lines would look like are two lines that do not intersect and go in the same direction. These are lines that have the same slope, as you will recall from Algebra 1. The symbol we use to write parallel looks like the two L's in the word parallel. It looks like two parallel lines. This is the symbol that means parallel. Perpendicular lines are lines that intersect at a right angle. Remember that a right angle measures 90 degrees. So the picture of perpendicular lines would be, here's one line, and here's a line crossing that first line at a 90-degree angle. Let's put that right angle mark at that intersection point to show that it's making a 90-degree angle. And you will recall from Algebra 1 that these lines have slopes whose product is -1, or we've also talked about the slopes being opposite reciprocals of each other. The symbol for perpendicular looks like perpendicular lines. Some people refer to it as an upside down T. This means perpendicular. The parallel postulate. Given a line, so we'll be given a line. So in a picture, I'm going to draw a line and a point not on the line. So anywhere not on the line is fine. There must be exactly one line through that point that will be parallel to the given line. What does that mean? I can draw lots of lines through this point. I can draw a line like this, or a line like this, or a line like this, but there is only one possible line that I can draw that will be going in the same direction, never intersecting this other line. Seems pretty straightforward, which is why it's a postulate. Postulates are accepted without proof. Perpendicular postulate, very similar. We're given a line and a point not on the line. But this time we say there is exactly one line through that point that will be perpendicular. Unlike this one was parallel, it would be perpendicular to the given line. So one exact way that I can draw a line that is perpendicular. Transversal. This is a line that intersects two other lines at different points. What does that mean? Here I'm going to draw two lines, and I'm not necessarily going to make them parallel because they don't have to be. And now I'm going to draw the transversal. Here's a transversal. It is a line that intersects two other lines at different points. From drawing a transversal, we've created a variety of angles. And now it's time to discuss the different types of angles created by a transversal. Let's begin with corresponding angles. These are angles in the same positions. What does that mean in the same position? Well, there's two intersection points. At each intersection point, there are four distinct angles. Angle 1, angle 2, angle 3, angle 4, as shown in that first intersection. Here's a second intersection where, again, we have four distinct angles. Now, if I look at this intersection, on the left side of the intersection, that angle right there, and instead of circling the angle, I'm going to show an angle mark. This angle right here is called angle 1. That's on the left side of the intersection. If I look at this intersection, on the left side of the intersection is angle 5. Therefore, angle 1 and angle 5 are corresponding angles. They are in the same position. They are both on the left side. Now, I could have picked a different pair of corresponding angles. Let's use another picture so that we don't confuse the pairs that we're choosing. Now, sometimes it's good to take a highlighter to notice the angles. Angle 1 is on the left side, angle 5 is on the left side. We don't even have to highlight that much, perhaps just the 1 and the 5, like that. So looking in this other intersection, here maybe I could pick an angle at the top of the intersection, like angle 2. At the top of this intersection would be angle 6. Therefore, I could say angle 2 and angle 6 are corresponding angles. That's all that means. They are angles in the same positions, such as angle 2 and angle 6. Let's look at another pair. Actually, let's compare alternate exterior angles and alternate interior angles by looking at them together. Now notice they're very similar in the wording. They both use the word alternate. Alternate refers to where, according to the transversal, is it. Alternate means on opposite sides of the transversal. So again, alternate means on opposite sides of the transversal. Remember the transversal, this guy that's crossing, the guy that's crossing both lines, the guy that's crossing both lines, okay? Crossing both lines. Now here's the difference between the two. We've got exterior. What does exterior sound like to you? That's right, it sounds like outside. What does interior sound like? That's right, that's inside. Specifically, we're going to relate it to being between or not between the two lines that are being crossed. So exterior, we're going to say not between, so that it's on the outside, not between the two lines, referring to the ones that are being crossed by the transversal, versus interior being between the two lines. So exterior, not between, interior, between. So let's look at not between first, the exterior one. So between the two lines, here are the two lines that are being crossed by the transversal. This is what's between or inside the two lines. I'm scribbling those out because I don't want to look at those. If I'm only using the exterior angles, those are the ones not between. Now we have to indicate which ones are on opposite sides of the transversal. So if I look at this intersection right here of 4 angles, I could pick maybe angle 1, this angle right here. And if I pick that angle and I look at the transversal, angle 1 is above it. So from the other intersection, I have to pick an angle below it. That would be angle 7. So an example of alternate exterior angles would be angle 1 and angle 7 from this picture. Let's take a look at the other diagram. Again, here are the two lines being crossed by the transversal. Let's scribble out what's inside since we want the exterior angles. Looking at the transversal, this time I could pick an angle below the transversal, and then opposite side from the other intersection would be something above. So angle 4 and angle 6 are also alternate exterior angles. Let's examine now the interior ones, the ones inside. So similarly to how I scribbled out the inside because I didn't want interior, now I want interior. So now I'm going to scribble out what's on the exterior. And let's go ahead and just do that for both of the diagrams so we can pick good angle pairs. Now I'm going to look at one intersection of two lines to give me 4 angles. I'm going to pick an angle like angle 2 that's above the transversal. In the other intersection, what's an angle below the transversal? Angle 8. So I've got angle 2 and angle 8 are alternate interior angles. Similarly, I can pick an angle below the transversal and an angle above the transversal, opposite sides of the transversal from the two intersections. Angle 3 and angle 5 are alternate interior angles. One last angle pair to explore, consecutive interior angles. Consecutive means on the same side of the transversal, not on opposite sides anymore, on the same side. And remember what interior means, between the two lines. The two lines being intersected by the transversal, so between. So again, I don't want any angles that are on the exterior. I'm going to scribble those out. Any angles on the exterior. But now I want them to be on the same side of the transversal. So here's the transversal. I'm going to look at this intersection, these two lines intersecting. Angle 2 is on the top. Looking at the other intersection, angle 5 is also on the top. That's the same side of the transversal. So angles 2 and 5 are consecutive interior angles. Angles 2 and 5. Similarly, here's the transversal. Angles 3 and 8 are on the same side of the transversal. Angles 3 and 8. Can you identify these different types of angles?